Today we are going to see electric dipole in uniform electric field. Okay, let us consider a uniform electric field in which we are placing a dipole and we are going to calculate torque for the dipole. Okay, now see the red lines. Okay, this is the electric field. It is a uniform electric field. How can we say uniform electric field? See the lines. These are all equally spaced electric field. The equally spaced lines. Therefore, we can say it is a uniform electric field, and in which we have placed a dipole. Dipole, as you know, it has two equal and opposite charges. Okay, that means minus q and plus q, separated by a distance 2a. Okay, it is kept at an angle. That means we are going to derive an expression and we can apply for various position. Therefore, we are deriving an expression at an angle with respect to the electric field. This is the direction of the electric field. The arrow is shown here, and the electric field is kept at a particular angle, that is theta, with respect to the direction of the electric field. Okay. Say this is plus q and this is minus q, and here this plus q acts in the direction of the electric field. That means it exerts a force. It exerts a force in the direction of the electric field, and minus q exerts a force in the opposite direction of the electric field. Okay. Due to that, a couple is formed. What is that couple? Already you know. In the mechanics, you know, equal and opposite forces constitute a couple. Equal and opposite forces constitute a couple. Okay. Due to that couple, the dipole tends to move. Okay. Tends to rotate. Not moving means it is not translated motion. Tend to rotate. Okay. Just like an example, cycle pedal. Okay. In a cycle pedal, one pedal is at the top, one pedal is at the bottom, and you are applying equal and opposite forces. Therefore, it is rotating. Okay. Just like this dipole will rotate in the uniform electric field, and there is no translational movement. Okay. That is you have to understand. In uniform electric field, only torque is there. Now we have to calculate the torque for the dipole. Okay. Already the formula you know. Okay. I am going to give a simple derivation only. Okay. Now F equal to QE, already you know. Okay. Force equal to charge into electric field, and dipole moment, that is also we have derived. Okay. 2a into q. This is the dipole moment, and 2a means distance between the two charges, and q is the charge. Okay. And torque equal to force into arm of the couple. Okay, force into arm of the couple. This is also already you learned from the lower classes. That means 11th standard you might have learned this formula. Okay. Now we have to substitute this force, and we have to calculate what is the distance r for this dipole placed in a electric field. Okay. See, this is the angle. Okay, in which the electric field is placed. The dipole is placed in electric field, and this is the angle which makes with the electric field. Okay. Now see the triangle ABC. Okay. Here this is the theta and this is the right angle. I have drawn this separately here. Okay. To understand, I have drawn separately ABC. Now this is the arm of the couple. This is the arm of the couple. Which one? BC. Now we have to calculate what is BC. Okay. Sin theta equal to BC by AB. Okay. If you cross multiply, you can get BC. AB equal to 2a sin theta. That means you are writing sin theta. Sin theta means opposite side by hypotenuse. Okay. And AB already you know 2a. Therefore, BC equal to 2a sin theta. Now you are substituting here, and you are substituting for this 2a cube, this one. Okay, P. Now you are getting PE sin theta. Okay. Now you are putting vector product. Therefore, P into E, which forms torque. Okay. That means torque depends on dipole moment and electric field, or it is a cross product, vector cross product of moment and electric field. Okay, intensity of the electric field. This is the simple derivation, but you have to remember what are all the special cases, okay, which depends on theta value, Now you are going to substitute theta value and for different cases, okay. Now when theta equal to 0, that means this dipole is along the electric field. That means positive charges here and negative charges here. That means in this angle, this is the dipole. Okay, this is positive and this is negative. Okay, now what happens? Torque equal to 0. When you put theta 0, as I told you, we are going to derive this derivation for particular angle. Therefore, we can apply for any position. That is our aim. Okay. Now, theta equal to 0 means torque equal to 0. That means it will be in alignment of the electric field, and it is called stable equilibrium. Okay. The torque is in a stable equilibrium. Okay. Then, when theta equal to 90, that means torque is perpendicular to the electric field. Okay, that means this is 90 degree. Theta is 90 degree. Then it has a maximum value. Torque equal to PE, maximum value, because sin theta equal to 1. Then theta equal to 180 degree. That means the torque is aligned in the opposite direction. This is P, this is plus, this is minus. Okay, that means in opposite direction. That means again torque equal to 0, but it is in unstable equilibrium. This is in unstable equilibrium. And torque equal to 270. That means both 90 and this are same, but sign varies. It is minus PE. Okay, and again 360 means it will go to theta equal to 0 position. Okay, these are all the some special cases. In uniform equilibrium, the torque is acting. There is no translational motion. But in non-uniform electric field, the torque will move. Translation also. There is some displacement also for the dipole moment. Okay, the dipole moves in a translational direction in a non-uniform electric field. In uniform electric field, it will not move. It will rotate only. Okay, this is the simple concept. You have to remember the formula and you have to remember the various cases only. Okay, because in filling the blanks or in objective type, they will ask this type of only. Okay, and derivation, they may ask for the 2 to 3 marks only. Thank you. Please subscribe and put a comment.